This video will help you review for your Unit 1 test test. So the first part of our video is going to talk about the conjugate, which simply means that you are changing the sign of what's in front of the imaginary part only. Everything else stays the same. So my real part does come down in my answer. I did not change the sign. I only change what's in front of my imaginary part. So that's my answer. That's all a conjugate means, okay? If I go to the next one, I notice that I only have the imaginary part, so I just change the sign. That's it. Moving to the next section. If I am asked to simplify and I have eyes, what I want to do is pay attention to my eye chart. So I'm going to show you more than one way to actually simplify these type problems, but you want to make sure your final answer as it pertains to I is what's in this highlighted area. So if I have I to the 14th, what I'm looking for are multiples of 4 because that's the highest. It's a pattern of 4. So it's going to be the number that I'm always dividing by if I choose to use long division. So let's try that. So 14 divided by 4 is 3. What's left over is what I'm focused on, which is my remainder. And I'm just going to put an I in front of it and look at my chart, and I see that I squared really is -1. So therefore, my answer for I to the 14th correlates to I squared, which is -1. If I were to use the calculator for this, I'm taking my exponent 14, and I'm going to divide it by 4 because again, my divisor is always 4. And I'm looking at the part that's after the decimal. So in this case, it's 0.5, which is the same as 0.50. When I look at my chart, 0.50 again correlates to -1. So that will always be the case if I am using my eye chart. If I go to the second example, what I want to do first is I want to pull down the numbers that are shown, including this sign, and I'm going to replace that I to the 63rd power and the I to the 82nd power with what's shown in my highlighted area on my eye chart. So how do I do that? Going back to my calculator, I take my exponent, which is 63, and I'm going to divide it by what? 4, always by 4. And if I look at my decimal portion, it tells me it's 0.75. 0.75 tells me that means it's going to be -I. So that's what I'm going to replace here. Let's do the other one using the long division. So if I took 82, which is this exponent, and I divide it by 4, I see that 4 times 2 gives me 8. But when I bring down this 2, there's nothing times 4 that can give me 2. So I just put a 0 there. And again, I'm looking for my remainder, which is 2. I go back to my chart, I squared correlates to -1. So that's what I'm going to put in my parentheses. Now at this point, I simplify. 2 times -I is -2I. -5 times -1 is +5. However, I want my answer to be in the correct form, which is A plus or minus BI. So that means that I'm just going to have to switch them around. And I have to make sure I keep up with my signs. So I have a +5 minus 2I. That is my answer. Now, if I go to the next section where we're performing the following operations, this one says find the product of the quantity of -3 plus 2I times the quantity of 2 minus I. That, again, product just means multiplication. So if you see that, know that you're multiplying. What we're going to do here is we're going to take the first term, -3, and multiply it times everything in the second set of parentheses. We're going to come back, take the second term, multiply it times everything in the second set of parentheses. You could also use the box method if you wanted to. So that's what I'm going to do. If I use the box method, then I take my first binomial set and I'm going to put it on the top. -3 plus 2I. You do not have to use this method. You can use the distributive method. And on the other side, 2 minus I. And then what I'm doing is I'm multiplying this row times these columns. And then I'm putting the answer in the box that correlates with it. So 2 times -3 is -6, and that goes in this box. 2 times +2i is +4i. -I times -3 is going to be +3i. And I like to keep up with my signs. -I times 2i is going to be -2i squared. So I wrote this on the outside of the box because I know that this I squared is going to go away, because based off of my chart above, I squared really means -1. So if I had a -2 next to a I squared, that means I'm multiplying. So -2 times -1 is actually a +2. So now what I want to do is take my real part, which is typically diagonally, and I want to combine them. So if I have a negative and a positive, that means I'm subtracting and taking the sign of the bigger number. So -6 plus 2 is -4. And then I take my imaginary part and I do the same. I have a +4i plus 3i. Since the signs are the same, that means I'm adding, and I just bring down that I. I do not try to square it or anything. Let's be consistent here. Boxing is fine as well. Just want to clearly identify your answer. So now I'm asked to subtract. Pay attention to this, because sometimes people get confused as to which one will have the signs change. So this word subtract, just go ahead and cross through it and put a minus sign. And then that tells you that the actual parentheses that's next to it is the one that's going to change signs. So negative times -6 is really going to be a +6. So what I'm going to do is just go ahead and line it up over here. And then negative times +3i is going to be a -3i. What you will notice is the signs are changing. If your signs are not changing, you are doing something incorrect, okay? Pay attention to that. So now all I have to do is just subtract or add, I'm sorry, simplify down. So -14 and +6 have different signs, so therefore I'm subtracting. And then the next one, 2i and -3i have different signs. So I'm going to subtract and take the sign of the bigger number. And that's my answer. It is in the correct form, a plus or minus bi form. And my B part is really a -1. The next one asks me to take the sum. Well, what's the sum? I'm adding. I can do the exact same thing. Just go ahead and combine like terms. I do not change the signs. I like to vertically do the math. So I'm just taking this and I'm lining it up under the like term. So I have a -4 plus 3i. That's because I'm adding based off of, I'm finding the sum. But if the signs are different, you're really subtracting. So the terminology, this is what you're paying attention to, but you actually are following the rules over here. All right, so then we're going to divide. Now, this is why you need to know what the conjugate is. So when we're dividing, we always want to go to the conjugate, which is the conjugate of the denominator only. And I told you earlier, conjugate means simply changing the sign of what's in front of your imaginary part. What you do to the top, you do to the bottom. Or proper terminology, what you do to the numerator, you do to the denominator. Now what I want to do is create 4 sets of parentheses. And I am going to multiply across the top. I told you a few minutes ago what you do. You take the first term, multiply times the second parentheses, everything in it, and you're going to do the same thing with the second term. Okay, that looked kind of messy. Let's change colors here. Okay. Not much better, but hopefully it'll help you follow it. 4 times 2 is 8. 4 times I is plus 4i. 3i times 2 is 6i. And then 3, just looking at the numbers, 3 times 1 is positive 3. And I know that I squared is going to change the sign. For those people who need to know what just happened, remember that chart, I squared, that's going to turn to -1. And then I take the 3 and multiply it times -1, which changes my sign. At the bottom, I will have 2 times 2 and then 2 times I. So that's going to be 4 plus 2i. And then I go back to my second term, including the sign, -i times 2 and negative I times positive I. So here, this time I'm going to have a negative 2I, and I have a negative 1I squared. And that I squared, again, turns into a negative 1. So negative 1 times negative 1, we're just going to change the sign, positive 1. Combine like terms. I see up here, I have an 8 and I have a negative 3. That's my real part. So I'm going to combine that, and that becomes 5. My imaginary part is this part in the middle. So that's 4I plus 6I, which is 10I. Then I go to my denominator. If I am doing my denominator correctly, this will always happen. The middle parts will go away because one is positive and one is negative. So what's left over is 4 plus 1. That's going to be my denominator for both fractions because this is two separate fractions, A plus or minus BI. But I can simplify this. 5 divided by 5 simply turns into 1. And then 10 divided by 5 turns into 2, but I have an I there. So plus 2I, because I'm taking this sign that's shown in the middle. And that is my final answer. You could put this in the calculator, and I will do a video later to show you how to use I's in the calculator and other ways that you can use your calculator to help you with solving problems. So this is, we're still performing multiple operations here. First thing you want to do is distribute. So I end up with 24 plus 8I, and then I do the same thing here. Negative 16 plus 2I, same thing here, distribute, paying attention to the signs, plus 15 minus 21I. Now I want to go and I want to look at everything that is the same. So I'm looking at my real parts. So I have a 24, a negative 16, positive 15. And if I were to add that together, let's go to our calculator. That was 24, negative 16, and I think I said positive 15. Yes, so that's going to be 23. That's my real part. Then I go back and I look at my imaginary part, plus 8I plus 2I, so that's 10I minus 21I. So again, let's go back to our calculator, make sure we're doing it right. 10 minus 21, and that's going to give us a negative 11. So make sure you keep up with your signs. But after that 11, I have an I. It is in A plus or minus BI form. So that's my final answer. If it was, try not to, don't write it backwards. Make sure you're in the right form. Okay, this next one confuses people. This simply means I'm going to take what's in my set of parentheses and multiply it times itself this many times. So 3 minus 4I. This time, well, no, I'm going to do the box method again, but just again to reiterate what's happening, you're taking this first term, multiplying times everything in the second set of parentheses, taking the second term, including the sign, and doing the same thing. I like the box. So 3 minus 4I is going to be on top, and then 3 minus 4I will be on the side. What you're doing is creating 4 boxes for your 4 terms, and you're multiplying 3 times 3, 3 times negative 4I, 3 times another negative 4I, so that means it's going to be the same answer. And on the outside, I'm just going to go ahead and write negative 4 times negative 4 is positive 16, but then I times I is I squared. By now, you should know that's negative 1, which means you're going to change your signs. Negative 16. You no longer have an I. All right, so then what you want to do is you want to combine your like terms, starting with your real part. So 9 minus 16 is going to leave us with the negative 7 as the real part. And then if I were to combine negative 12I and negative 12I, the signs are the same. That means I'm adding. So negative 24I. It is still in A plus BI form. So that's my answer for this one. Now let's move on to solving. And when you solve, if you can, further simplify. This is the part that confuses people. That is kind of, if you just visualize everything that's in the set of parentheses, it's just like saying x squared. Okay, so don't get confused when I ask you to isolate your x squared variable. I mean, your variable squared, that's what I'm referring to if it's in parentheses. So if you ever have anything before or after, you have to get after that squared. Before or after the square, you have to get rid of it first before you can start square rooting. So what do I have before? A 2. So I'm going to get rid of that 2. It's going to bring down what's left over, which is x minus 7 squared equals. Now, pay attention. I have a negative 24 and I'm trying to divide it by 2. That's going to leave me with a negative 12. At this point, I do not have anything before my parentheses or after the square. So I can start square rooting. Square root, and I told you on this side, before you do the square root, always write plus or minus, and then square root. I think my computer is getting hot. It's doing something crazy. So now, the purpose of doing that was to get rid of, I'm doing the inverse, to get rid of that square. I'm going to bring down x minus 7, set it equal to plus or minus. Now, at this point, I can actually factor the negative 12. I already know this negative is going to factor out as an I, because that's really the square root of negative 1, which we know is I. And then I can take a 4 times 3, and since the square root of, since 12 is under the square root, so will my factors be. Well, square root of 4 is really 2. So that's what's coming out, 2i square root of 3. You could write 2 square root of 3i. Just make sure that I is not under the radical. I just like to put mine in front. At this point, x is not by itself. So how do I get it by itself? I have to add 7. Why am I adding? Because it's already, I'm trying to do the inverse. So the opposite sign of a negative. So what I do to one side, I do to the other. Some of you will try to combine these numbers. You cannot combine them, because if you're looking at the radical portion, all of this is one number. So the plus and minus goes with that 2i cubed. That is not, okay, I don't know what just happened, but my computer is doing something crazy here. Okay, so the plus or minus 2i radical 3 is one number. So I can't combine that 7 with it. But now if I put the real part first, it's a positive 7 plus or minus 2i radical 3. That's my final answer. 2 other ways I will accept that is if you take it apart. So x could equal 7 plus 2i radical 3 and 7 minus 2i radical 3. So that's what this part means, the plus or minus. And the other way is, like I said before, if you wanted to put the I afterwards. So x is equal to 7 plus 2 radical 3 with the I is clearly not under it, and 7 minus 2 radical 3, and the I is clearly not under it. So that's acceptable. Another way that you would see a problem that asks you to solve and then simplify is like this. Well, this time, again, I'm trying to, my whole goal is to isolate the squared variable. I have something before and after. If I have something before and after, my first choice is to get rid of what's after. So I want to get that negative, the positive 16 to the other side, which means I have to switch signs. When I do that, I'm left with 4x squared is equal to 72 minus 16, which is going to be 56. All right, and then after that point, what I want to do is divide both sides by what's stopping x squared from being by itself. It's 4. And now my x squared variable is by itself. 56 divided by 4 is 14, but this is not x, this is x squared. So in order to get rid of that, the inverse is to take the square root. When I take the square root on that side, it's getting rid of that square. But on this other side, I have to do a plus or minus and then take the square root. Now what's happening is I'm bringing down my radicand x. So x is by itself. X is equal to two answers, plus or minus square root of 14. That is my answer. And again, you can take it apart if you wanted to. You can have one plus and then one minus. My last section is factoring. So when you're factoring completely, you have to make sure you're following rules. The first rule is to put it in standard form, meaning the highest exponent goes first, and then you start counting down. So I'm going to rewrite this as 9x squared. This has a negative sign, so keep up with that, minus 36x. My second step is to factor out any kind of greatest common factor that I can see between the two. What I see is I can divide both of these by not only 9, but also by 1x, so 9x. What I take out or what I divide by, that goes in front of my parentheses. So whatever this is, it's in my answer. It's going to go out front of the parentheses. What's left over? 9 divided by 9 is 1. X squared divided by x is simply 1 more x left over. How do I know that's right? Because x times x gives me my x squared. I will end up right back where I started if I'm doing it correctly. Bring down this sign. What's 36 divided by 9? It's 4. X divided by itself is simply 1, so I no longer need that. And I can't do anything else. So this is my final factored form. And it has parentheses in it. Next thing I want to do is look at the second one. So there's multiple ways to factor. You do not have to use my method. You can use the area model, or since this is a difference of two squares, meaning I have two perfect squares with a minus sign in between, the easiest way to do it is to just take the square root of both of the first and the last term, which is going to leave me with 4x. And this is 7. Actually, it's plus or minus 7. And what that is my answer. I just have to put it in factor form, which means I'm going to have parentheses. So in one set of parentheses, I'm going to take this 4x, and then I'm going to take the plus sign and put it over here with the 7. And the next one, I'm going to take that same 4x, but this time I'm going to use the minus sign with the 7. Ta-da! I'm finished. Be consistent. Let's see here. And if I want to know if I'm doing it correctly, again, multiply it out. 4x times 4x is 16x squared. That's what I started with. The middle term will go away because there's a plus and a minus of the same number. And then the last term, 7 times negative 7, will give me that negative 49. That's how you know you're doing it right. Take the time to go back and check your work. All right, for this one, let's go ahead and do the box method. So you'll have options here. You're used to doing the box method when the factors are on top, but let's just use what we have here. The first term always goes in the first box. The last term, including that sign, goes in the last box. You are trying to replace negative 1x. Therefore, you will have an x next to whatever you are trying to replace that with. So what do? You take the numbers a and c, which are 2 and negative 6, and you try to find two factors that will not only multiply to give you negative 12, but they will also add to give you negative 1 because you're trying to replace that. So I can think of 4 times 3, but I have to pay attention to my signs. The bigger number, so the word bigger starts with B, right? So whatever the bigger number is in my factors, it's going to take B, the sign of B. All right, my bigger number happens to be 4. So I know it's going to be a negative. Because there is a negative sign in front of my C, for those who don't know what I'm talking about, A, B, and C, the standard form of a quadratic is ax squared plus bx plus c, where you're multiplying a times c, which is what we just did, and you're trying to find factors that will add to give you b. So I found that negative 4 and positive 3 not only equal negative 12 when I multiply them, but when I add them, they're negative 1. So I know that's what I'm working with. It doesn't matter which one goes in which box. They're going to be factored out, so it doesn't matter. So what do? Going to the left, first, I'm going to factor out the greatest common factor between 2x squared and negative 2. So I know that I can equally divide both of those by 2x. And what sign am I using? I'm always using the sign that's closest to where I'm writing. So just the highlighted part. So if I go to the next row, what's the greatest common factor? What's the biggest number I can divide both those by? Plus 3. I would not include a variable this time because this one doesn't have a variable. So they don't have that in common, right? So now what I'm going to do is go vertical. I can try to do the same method and factor it out, or I can ask myself 2x times what will give me 2x squared. And just looking at that, then I know that it's simply x. 2x times what will give me negative 4x. Well, the x is already accounted for, so therefore it has to be a negative 2. Also, this sign is closest to where I'm writing, so that's why I took the negative out. This sign is closest to where I'm writing, that's why I took the positive out. If I wanted to check to make sure this is correct, because this is not the form that I leave it in, but these are my factored answers, I have to write it with parentheses. Going from top down, I notice some of you are writing it backwards, and also from left to right. That's how you write it. So 2x plus 3 times x minus 2. This is your answer. The next question I get, well, can I write it as x minus 2 times 2x plus 3? Yes, you can. Why? Because if I ask you what's 4 times 3, you would tell me 12, right? And if I said, well, what's 3 times 4? Guess what? It's still 12, and you swap them around. So it's okay to change your binomial factors around. That's good. It's not a problem to do that. All right, so number 4, what you're doing is you're trying to factor again, but this time you want to make sure you put it in standard form. My leading coefficient, my highest exponent is 2, so I want to write it in that order. 6x, 64, sorry about that. 64x squared minus 16x, you got to keep up with your signs, plus 1. Again, I'm a box person, so I'm going to use my box. My first term is what goes in the first box, 64x squared. You do not have to use this method. Plus 1, that's my last term, that goes in my last box. I multiply those two numbers, and I'm trying to find factors that will not only multiply to give me a positive 64, but they're going to add up to give me a negative 16. Pay attention to the signs. Well, what would that be? Well, I know it's 8 times 8, but does 8 plus 8 give me negative 16? No, so that means I have to check my signs. So now it does. And now once I put that in here, I have to remember I'm replacing the entire term, negative 16x. So therefore, this has to have an x with it. If not, when you factor going across, what you're going to do is bring out just an 8. And then when you factor here, what you're going to do is just bring out a negative 1. That doesn't look right, correct? That's why you have to make sure that you put your variables in all 3 of these boxes when you have a quadratic, when you have a trinomial that looks like this. So let's go back, and for that first row, you have to have that x as well, because that's the greatest common factor. So if I'm going up to the top, and again, I can do the same thing. 8x times what is going to give me 64x squared? Well, it's going to be the same thing, 8x. Or you can just ask yourself, what's the greatest factor between negative 8 and positive 1? Well, there's nothing else except 1. However, because this box is closest to where I'm writing, I have to also take out the negative. If I am paying attention here, I see, oh, they're exactly the same. So pay attention to the signs. So some of you will write it as 8x minus 1 times another 8x minus 1, but it's really the quantity of 8x minus 1 squared. I'll take both. Okay, it means the same thing. Number 5, here you will have to know the formula for the area of a rectangle. So the formula is area equals length times width. Well, you're given the area and you're given the width. I apologize that my computer is doing whatever it's doing. So now what I want to do is I want to actually set this up to try to figure out, you could use the box method. That's what I would do because that's just what I'm used to. But when I'm using the box method, I'm focused on the area portion of it. So what am I going to put in the first box? The first term. What am I putting in the last box? The last term. And what am I trying to find factors of? This time you want to take negative 18 and you want to multiply times 2. For those who need a calculator, that would be, the negative is under the 3, 18 times 2, or 18 plus 18, but just don't forget your negative, which is going to be negative 36. And you're trying to find 2 factors that when you add them together will give you a positive 5x. So I can think of 9 and 4, but I have to look at my signs. The sign of the bigger factor takes the sign of whatever b is. So since b is positive, then this 9 is going to be positive. And then the other sign will be negative because the sign in front of c is a minus sign. That means the signs are going to be different. It does not matter which position that I put the 9 and the negative 4 in. I can put the negative 4 here, or I can put the positive 9. What I have to remember is whatever that variable is, I have to include it. So plus 9x. Going to the left, I want to take the greatest common factor between that first row, which I can look at it and I see that it's going to be 2x. And then I want to take the greatest common factor of the second row. And what can both of those be divided by evenly? And it's going to be a positive 9. Again, I'm taking the sign of what's closest to me. Both of those are positive, so both of the signs are positive. All right, so let's see. This is what we were given in the problem that should go on top because it differs from what we just came up with. So let's see if we're on the right track. So if I'm going up, 2x times what will give me 2x squared? Well, that's an x. If I'm looking this way, 2x times what will give me negative 4x? Come on, computer. Sorry, my computer is doing something again. That's going to be, remember the sign, is going to be negative 2. Well, wow, we must be doing this right because this is what was given already. So therefore, if it's asking me to find the length, my answer must be this other part, 2x plus 9. But do I leave it like this? No, I put it in parentheses. This actually should have been in parentheses. That's the way I would like to write it anyway. So that's my answer. And if I were to multiply this out, it would end up right back where I started with my area. And then the last example. So let me highlight my final answer. This is my final answer. They were just asking for the length. And given that one of the factors of 50x squared minus 55x plus 15 is this, so you're already given one of the factors. What are the other 2 factors? So let's go ahead and write this out here. 50x squared minus 55x plus 15. First thing that I notice is I can divide out a greatest common factor because it's already in standard form. So I'm going to go ahead and divide everything by 5. I don't have a variable to divide out because this one does not have a variable. So 50, whatever I divided out, goes on the outside. 50 divided by 5 is 10, and I'm still left with x squared. So when I multiply this out, I should end up right back where I started. So 50x squared is where I started. Then let's go ahead and get rid of that. I have negative 55 divided by 5, which is negative 11. I bring that x down, and then I have a 15 divided by 5, which is 3. So I see already that's one factor. So I have one of my answers. Now what I do to find my other factor is, if you're using my method, you want to use the box method of only what's left in your set of parentheses. The first box takes the first term, 10x squared. The last box takes the last term, which is 3, positive 3. I'm looking for factors of 10 times 3. So 10 times 3 is 30. And those two factors have to add to give me a negative 11x. So I know I'm going to put the x here. And I can think of 6 and I can think of 5. But if I use positive 6 and 5, I'm going to have a positive 11. I don't want a positive 11. So the same signs would have to be the case. So negative 6 plus negative 5 is negative 11, and it multiplies to give me a positive 30. So that's what I'm going to put here. So negative 6 and negative 5. Factor out the greatest common factor of the first row, the second row, the first column, and the second column. So the greatest common factor is going to be a, for the first one, it's going to be positive 2x. And for the second one, it's going to be a negative, oh, it looks like I did something wrong, but a negative 3 here. And then when I go to the top one, it's going to be what it was supposed to be. Let's see, 10. That's not right. Where did I get that from? Duh, that's why it's not right. That should be a 5. I apologize. So the greatest common factor is a positive 5. So now going up, the greatest common factor is a positive 2x. And if I look at these numbers, there's really nothing I can use except for a 1. But again, I have to take this sign with it. So negative 1. That's my answer. That's what I was looking for. So my final answer should be 5 times 2x minus 1. And again, it doesn't matter which one you use first. And we were already given this 5x minus 3. We were given that in the problem. So this is my final answer. Actually, that's not my final answer. You were only asked to find 2. Your final answer was 5 and the quantity of 2x minus 1. But the entire answer is what I was trying to highlight to begin with. Hope that helped you guys. Go ahead if it did and give me a thumbs up, and definitely subscribe and click that notification bell so that you are aware when I am uploading videos. Have a great day.